Hey guys, today we're going to go over your Lavoisier Lab, and it is in chapter 3, and it primarily deals with the law of conservation of matter. So it's a really neat lab, and we're going to go through it here today. So if you missed it, you'll have an opportunity to see what it's about. So the first thing we want to do is we want to take a little piece of magnesium, and we're going to look at some of its qualitative properties. And again, quantitative deals with numbers, qualitative is just the descriptive things. Okay, so I can see it's silver, it's shiny, it has some luster, it's kind of light, it's a solid at room temperature. Okay, a lot of my students said it was a metal, but I thought that was kind of pushing it. They didn't know it was a metal. I think that's more of an inference, but that's what they had for some of their qualitative properties. Now, after they did that, we got to burn it. And when you do this, you have to be careful and not look directly at it, because it burns bright enough it'll actually hurt your eyes. So you just kind of want to look at it out of your peripheral vision. So as soon as I get it going here, I'll kind of look away. I'm anxious to see how this goes on camera. Woo, man, that's bright. That is really bright stuff. And here's what's neat. Look at this stuff when we're done. It's a white powdery substance. So if I tap it, of course it doesn't do anything, there we go. You can see that white powder fall down. All right, so that's a totally different substance altogether. Now, when I think of qualitative product or properties of that product, well, I would just say it's white, it's powdery, would be about all I could really recognize. What kind of evidence of a reaction did we have? If we think back about chemical reactions, then we definitely had production of light and heat. So those would be the big things we would identify. Now the next step of this lab is you're going to take your scale here and you're going to zero it out, and you're going to place magnesium on it until you get up to 0.24 grams, or as close as you can. Okay, so there's 0.24 grams for me. So once I have that, I'm going to take a crucible and lid, and I'm going to weigh them, and I'm going to record that measurement. So I've got 0.24 grams of magnesium. I've got 19.60 grams for my crucible and lid. Now if I want to cheat a little bit, I can look down here and it says total mass before, and I'm going to go ahead and write in, I want to add those together, and it's 19.84 grams. That's my magnesium and my crucible. So once I do that, I'm going to go ahead and take my magnesium, and it's okay to bend it, and I'm going to put it in my crucible. I'm going to put the lid on it. Now one thing that's really important, and you'll know why later, is I'm going to put it in here where I can heat it, but I'm going to crack the lid. I want to keep it covering it as much as I can, but I need to crack that lid. We're also using a ring stand and a little ceramic triangle to support it. After I do that, and I've got my lid cracked, I'm going to go ahead and light my Bunsen, and I'm going to let that heat for 10 minutes. Okay? And I can take my tongs and I can check periodically to see how it's doing. And what I would like to see, I have to be careful, I don't want to lose any of the product, but what I'd like to see is I'd like to see it turning white. Remember that white powder we had when we burned it? I'd like to see that happening on the inside. So I'm going to let it burn for about 10 minutes. And once I do that, I'm going to take it off the table or off the ring stand here, set it down. I'm going to make sure the lid's over it, and I'm going to let it cool. Once it cools so that I don't burn my scale, I'm going to take this. I've got a pre-done sample. I'm going to take it, pick it up, put it on my scale, and weigh it again. Now before I weigh it, I want to predict what do I think is happening. And almost all of my students go, well, I burn wood, and when I burn wood it gets lighter. So it weighed 19.84 before. Most of them said it was going to weigh about 19.7 afterwards. That's what most of them guessed. That was kind of our average. So I put it on there, and the funny thing that happens is now it weighs 20.00 grams. So it actually gained weight. It gained 0.16 grams, and nobody understands that because they burned it, right? There's less of it. So let's look back and let's do some of the math. Now, you guys don't really know this yet, but Anytime we burn anything, we add oxygen to it. So any compound that I burn, generally we'll just add plus O2. So in this case, we're burning magnesium. And we burn the magnesium, so we add plus O2, and it actually creates a new product. It creates MgO. Now, when we balance this, oxygen is going to be it's going to be in 2s. So we end up with 2 Mg plus O2 will yield 2 MgO. The thing that we need to look at is both of these, the reactant Mg and the product MgO, have a coefficient both of 2. So they're a 1-to-1 ratio. Okay. So if I started with 1 mole of this, I should have 1 mole of this produced. Now, let's look a little further. When I start doing my molar masses of magnesium, I see it weighs 24 grams per mole. Okay? And then when I do my molar mass of magnesium oxide, MgO, I see that it should be 40 grams per mole. Since I started with 1/100th of a mole of magnesium, instead of having 24 grams, I had 0.24 grams, then in my head I can go, okay, I should end with 1/100th of a mole of magnesium oxide. Instead of having 40, I should have 0.40. And when I do the math, that's exactly what I ended up with, because we did it perfect. Okay, but that's why it gained mass. It's actually pulling the oxygen out of the air and combining it with the magnesium. You never think about oxygen having weight, but it does. So when it combines, it adds that mass. All my kids said, well, what about wood? When I burn wood, it weighs less. Well, anything that has hydrogen in it, right? Anything that has water, it's going to combine with oxygen, and that water is going to evaporate, and we're going to lose it. The other thing is, and some of my students didn't get a great result, but heat rises, and when I'm burning that magnesium, if I've got the lid over too far or I'm too anxious and I keep peeking, what happens is the hot air will carry some of that soot out, right? Some of that leftover magnesium oxide, and I'll actually lose weight that way. And in a fire outside, most of it burns away in ash. So that's the reason you have a loss of mass there, and that's the reason we actually gained mass here. Now the last thing I want to talk about, and just real briefly, because you'll hit it hard in a couple chapters, is limiting and excess reagent. So the two reactants, the two things that were involved in the reaction initially, were magnesium and oxygen. And I asked my students, which one do you think is limiting and which one's excess? And they thought about it a while, and they actually got this answer, but oxygen was excess. We had a whole room full of oxygen. That reaction, if it only depended on the oxygen, could keep happening and happening and happening and happening and happening. But I only had 0.24 grams of magnesium. So as soon as all of that magnesium had turned to magnesium oxide, no more reaction could occur. Even though I still had a lot of oxygen left, I had no more magnesium. So magnesium was the limiting reactant. Oxygen was the excess reactant. So it's a very good lab. The neat thing was that we got a different answer than what we expected, but then we can see why we got that. So I hope you enjoyed. Thank you very much.